Have you ever wondered why the seemingly serene white dwarf stars have an insatiable appetite for heavy metals? When we gaze up at the night sky, we're observing a vast cosmic tableau teeming with stars of all types. Among these, white dwarf stars hold a unique place. These are the remnants of stars that have exhausted their nuclear fuel and collapsed into a dense core. But there's something peculiar about them. They seem to have a taste for heavy metals. Now, ordinarily, stars are composed primarily of hydrogen and helium with traces of heavier elements. But white dwarfs defy this norm, possessing a significant amount of heavy metals in their atmospheres. This is an astronomical anomaly that has puzzled scientists for years. What is it about these stellar remnants that makes them so metal-hungry? And how do these heavy metals find their way into the atmospheres of white dwarfs? As we delve deeper, prepare to be amazed by the intriguing cosmic culinary habits of these celestial bodies. Picture a celestial buffet, where the white dwarf stars feast on a menu of heavy metals. Now, this might sound like a strange meal choice, but in the vast cosmic kitchen, it's a regular occurrence. To understand this phenomenon, let's first look at these white dwarf stars. These are stars that have exhausted their nuclear fuel and have shrunk to roughly the size of Earth. Yet, they retain a mass comparable to the Sun, which means they have incredibly high gravity. Now, this is where the heavy metals come into play. Think of these heavy metals as the main course at our stellar banquet. These elements, like iron and nickel, are not native to the white dwarf. They're delivered by asteroids and other celestial bodies that stray too close and get pulled in by the star's strong gravitational field. As these metals start to accumulate on the surface of the white dwarf, something fascinating happens. Due to the star's high gravity, these heavy metals begin to sink into the star's interior, much like a sumptuous dish sinking into the stomach after a hearty meal. This process is known as accretion. Accretion is vital to our cosmic dining experience. It's the method by which these white dwarfs consume the heavy metals. As the metals sink, they're subjected to intense pressures and temperatures, causing them to undergo nuclear reactions. This transforms the star's composition over time, and interestingly, helps astronomers understand the history and future of these enigmatic stars. But like any good meal, it leaves us wanting more. The more we learn about these white dwarfs and their metallic meals, the more questions arise. How does this process affect the star's lifespan? What happens when the star is completely saturated with heavy metals? In the grand dining hall of the cosmos, the white dwarf stars continue their feast, leaving us with more questions than answers. And as they dine, we'll continue to observe, to learn, and to marvel at the incredible spectacle that is our universe. So what does this stellar feast mean for us, and why should we care? It's not just about a celestial spectacle. It's a key to unlocking deeper mysteries of the cosmos. When white dwarf stars consume heavy metals, it paints a vivid picture of stellar evolution and the life cycle of stars. Just like a caterpillar morphing into a butterfly, stars too undergo dramatic transformations, and this phenomenon is a crucial chapter in that story. Moreover, it provides us with unique insights into the chemical composition of the universe. The heavy metals that white dwarfs devour are like cosmic breadcrumbs, leading us to a better understanding of what our universe is made of. Furthermore, this process influences the formation of other celestial bodies. These metallic meals might just be the raw materials for future planets, asteroids, or even other stars. As we continue to explore the universe, remember, each star, each white dwarf holds a story that adds another piece to the cosmic jigsaw puzzle.